Hi guys, welcome to this section on data structures. So we will start with a simple problem, TwoSum. So this problem is basically defined as given an array of integers. So just integers and an integer target, return indices or the numbers itself where the sum of those two numbers in the array add up to the target. So basically what they're asking is if the target is 2, 7, 11, 15 and the target is 9, then 2 plus 7 is 9. So the output is 0 and 1 because 2, which is the 0th element, and 7, which is the first element, make up 9. And if you see here, 3 to 4, the target is 6, so 4 and 2 make 6. So basically we need to return 1 and 2. If the target is 6 and array is 3, 3, we need to return 0 and 1. Generally, people just come up with a brute force solution. So they run two for loops, one running from 0 to n and the other running from 1 to n. And they just check all the combinations of the numbers, and that of course gives the solution, but that is a brute force solution. So why we call it brute force is because that is like the normal first level solution. Nobody in an interview should look for a brute force solution. If somebody has asked you a question, most probably they want an enhanced answer, which will reduce the time complexity. So if you don't remember time complexity, order of O or null, please go and revise it. So if you do a brute force solution, it will be order of n square. But what they are looking for mostly when they ask this question is an order of n solution. So how we do that is, so suppose we have this array which is 2, 7, 11 and 3. Okay, so basically the solution is to keep a hash map. So hash map is generally the solution to all simple level problems. So if you are stuck somewhere, think of a hash map and solution might come to you. So how we do this in one iteration itself? So we'll only go from 2 to 3 once. So our order will be actually order of n because we are only traversing the array once. How we do this is we keep a hash map, and what we actually store is, so even if you see the code here that is actually running, we are creating a hash map and we are running from 0 to n minus 1, and we are checking if the map contains key num of I. Okay, why we are doing that? Why we are just checking key is because if we don't find it, we are putting target minus num of I and I. So basically what is happening is, if we go back to an array, when we go to 2, so map is empty, nothing will be there. So in the map, we are going to add two values. Target, which is 9, minus num of I. So I is 0. I is 0. This is 1, this is 2, this is 3. So 9 minus num of I, basically our array, is 7. So 7 becomes our key. We store 7 in key because we can only search a hash map based on key, and value searching is really hard. When we search based on key, the search is based on order of 1, so our overall order does not increase. But if we start searching by values, it will again become order of n square. So please keep this in mind, and we will put I, which is 0 here. Okay, so in our hash map, so this is our map, we are basically having 7, 0. Now as soon as I becomes 1, we are searching for contains key, if you remember. So we will check the map. Okay, we have I, num of I, which means that the difference with the target is present in the map at this position. So we can just return this I which is stored in the map plus the current I. So 0, 1. So this is our answer. Now if you see the code, it is the same. We initialize a new hash map and we go from 0 to nums of length, and we check if map.contains key num of I, return map.get num of I, which means it will fetch this from the map, the first index, so the number which is our pair, and the current I, so 0, 1. Otherwise we take the difference and put this number for future. So suppose so let's suppose whether it was 11, then 13, then 7, then 2, then we would have ended up having these things in the map. So let me remove this also. So then basically our map would have been 9 minus 11, which is minus 2, comma 0, and then we will put minus 4, comma 1, then we will put 2, comma 2, and then finally when we go to the last I, we will get this 2 is already present, so we will return 2, comma 3. That would be our answer. So the idea, if you can get from all this explanation, is that we find the pair of every number and store it in the hash map. So pair means the number which if added to us would become the target. So we find the pair, we put it in the map, and then we keep looking for each when we iterate over the array, we keep looking if our pair has been found. If the pair has been found, we know for sure, okay, the current number plus the pair is equal to target, so we return those two indices. Now there is one more variation of TwoSum, which is actually ThreeSum, which means you need to find 3 numbers in the array which sum up to a given target. So for ThreeSum, we still use the same method. For every number in the array, we find TwoSum. So basically, if hold on. So for ThreeSum, basically, if you see my solution, we have calculated the TwoSum, and then for every number we are running a ThreeSum. Every number we are running the TwoSum. So basically, if the target is 9 and we are trying to find, so let's take an array. So 1, 2, 3, 4. So if our target is say 6, for 1 we will run the TwoSum where the array will be from 1 to n or n minus 1, and target will be 5. So this is one of the way which you can solve the ThreeSum problem. So there are some other variations of ThreeSum where you have to find the closest ThreeSum. So that requires you to actually sort the array. I would highly recommend you to go through the LeetCode forums for all those. So see you in the next one.